Welcome to this Blueprint Tips video. My goal here is to show you a variety of common and lesser known things to make your Unreal blueprints more efficient, clean, and easier to use. I've been a technical artist in the game industry for a while now, and I've been working with Unreal for just about as long. Most of what I will cover here are pretty common issues that I run into with others and that are both new to Unreal and those that have used it for some time. So hopefully they're useful for just about everyone. So let's dive in. Tick. It's one of the biggest and most often covered topics with blueprints, but it is definitely worth a reminder or a intro for anyone who's new to it. The tick refers to how often any of the functionality that you add after the tick node will be run during the game, and the more complex that functionality is, the heavier it is, especially if it's ticking every frame. This tick rate on the top right is what that refers to. The default of 0 means it's running every single frame. Quite often you can set this tick rate to be something other than 0, so it's running less often. If it were to be 0.5, then it's running once every half a second, and that can save quite a load, especially if there are many objects running. Avoiding tick and disabling it altogether is good, but when you can't, there's a couple options on top of adjusting the tick rate. This render check I'm showing you here is a great option just to make sure any complex tick operations aren't being run when something is completely out of view. Another trick of sorts is to disable tick by default or with this actor tick enabled, and then either with a timer or a custom event you re-enable tick for as long as it's needed and then again disable it afterwards. Timelines are another good option for a tick-like functionality. Just keep in mind that these always run every frame whenever they're active. They give you a little more control of the speed of what's being played or animated, as well as a curve to ease into things or give a bounce. The BeginPlay node is really useful for a variety of options. If you want to set a color on an object at random, or maybe set the strength of a new enemy, you can do that with this. There's just a few things to keep in mind, especially with regards to timing. When it says BeginPlay, it doesn't mean necessarily when the game begins, but when this object is either spawned into the world or activated. That means the timing's not always easy to guarantee. So if you're doing something with the BeginPlay node, it should usually only refer to this blueprint, not anything else in the world. If you're going to try to get other characters in the world like I'm showing here, that's something you'd probably want to do with a custom event or something that you can directly time and directly control. You can fudge the timing with a delay node. A lot of people will do that, but that's almost guaranteed to give you bugs at some point. Next up, let's dive into valid checks. These are a good habit to form pretty much in any use with blueprints. It's a good way to avoid bugs down the road and as well as give you a few options for when something isn't set, so you can always branch off. One nice feature though with most parameters is you can convert them to a valid get instead of having to run the branch and is valid. You can merge them all down to a single node with both outputs. Here I'm just using the false as a quick print to let me know that the actor was not set. It's a nice option for quickly debugging or prototyping, just to see if your functionality is working too. One little mini tip here is you see the compiler error. It's because the transform node on the spawn actor requires an input, but if you right click that pin and split it into its individual components, then it's fine as is. You can even input your own values directly if you want. Casting is another very popular blueprint subject. When to cast, when not to. Some say never cast, which never say never. Casting to an actor or a class is usually required to let this current blueprint know what the other type can do, what its functionality is, what parameters it has, and that you can set. But why a lot of people say to avoid casting is because when you do the cast, and even when you include it in this blueprint, you essentially load it into memory. So it's always referenced, it's part of the memory set of this blueprint. So if you're not careful, you can bloat an otherwise simple blueprint into something that can basically load the entire game, all of your textures, all of your characters. It's a lot. And that's a reference to hard and soft references that we'll get into later. Let's start with some good reasons to cast. Whenever you're going to reference something that's very light, like a base class, or something that you know is always active or loaded, like a game mode, the game instance, the character class is almost always available. Those are fine to cast to because they're already in memory or pretty much guaranteed to be. What you don't want to cast to is something heavier, something more filled out, like maybe a boss character that has its mesh, its textures, animations, all that data. In that case, blueprint interfaces are a great option. You can create one by right-clicking in the content browser and start typing interface and then select the blueprint interface when it comes up. I like to name them BPI underscore whatever they're going to be used with. You can set up any number of functions as well as the inputs and outputs for each of those functions within the interface. Just keep in mind that this is basically a kind of a shell level holder for those functions. The functionality itself will be called within whatever blueprint is using these interfaces. To make use of this interface, you first need to implement it in any or all of your blueprints. Like I'm doing here, you select the top level and the components, switch to the class settings tab, and then under the implemented interfaces, just search for whatever you named your BPI. Now you can open that function within this blueprint's interface function list, and in there you add the actual functionality. Now back in that first blueprint we were working with, and instead of casting to, here you just call up the name of the interface function. The target pin is whatever actor or object you want to hope to run this function on. And it's only actually called if that blueprint does indeed use the interface. It's kind of a nice free check. You could still call that function through a cast, but again, you'd be loading all of that other blueprint's memory and data into this blueprint all the time. Let's dig into some blueprint organization now with custom events, functions, comments, and other organizational methods. When you're first prototyping, it's fine to have big chains of nodes and loops and all run into each other. It's building out further and further where you have to zoom out to max just to see. But the further along you go, and especially with bigger projects, the more you want to consider some of these organizational tips, both for your own sanity as well as any other team members. Everyone will be happier with it. This first one is a good rule of thumb in programming, but definitely applies to blueprints as well, and that is don't repeat yourself. If you find that a lot of your blueprint is essentially the same functionality over and over again, but with just minor tweaks here and there, it's almost guaranteed that you can collapse that down into a function and simply reuse that function in each of those spots. Here you can see these little groups of print strings. They're simple, but they are doing the same thing, just with minor tweaks to the text. So why not grab all those nodes, collapse them down to a function, and then leave the text input to be the one unique thing that you can change per use. Once you've made one of these custom functions, you can call it in the usual manner by right-clicking and searching for it. You can also drag it in from the side, or you can just duplicate an existing one. You can pretty easily add extra inputs and outputs for any of these nodes as well, so if you come across something that is very similar to a function you've already done, but you need a slight tweak, you can do that like this. So the original function was just running 3 print strings, but here we run 2 and then this audio spawner. And to keep the original 2 from spawning audio when you don't want it, you simply add the bool, and then you can use that as a branch back within the original function, and it now works for both. And there are many other ways to do that too. You can run a selector to split different options. You can, based off of an enum input or a structure with various inputs, it has a lot of options. Another tool for organizing your blueprints is the collapse to macro option. This one is similar to the collapse to function, except that it's more just organizational. It keeps things as they were, just within another tab now. Next option is custom events. This is a great way to break up your graph so you're not continuously chaining nodes and loops and other endless messes. This is also a nice option for reusing any sections of code, as you can call these custom events from pretty much anywhere else. Also, they can be called from other blueprints, just like what we created with the blueprint interface functions. Comment boxes are another really helpful and useful option to use within your blueprints. Not only can they make a very large blueprint much easier to browse and read, but you can leave notes both to yourself and your teammates as to what each section is intended to do, if there are other features you'd like to add to it, or if you come across a bug that you can't figure out, to leave a note about it here. It's also really helpful to remember that not only can you add text to these, but you can change the color and enable the bubble text when it's zoomed way out, so you get a high level kind of a bullet point reminder of this is a section I need to zoom in for this feature. Individual node comments are pretty handy too if you need something more specific or a good reminder to yourself or someone else what a particular small section does. You can add them to pretty much any node too, just keep in mind that they're pretty small, they don't get that zoomed out bubble text. So Parameter descriptions and the hover tooltip text that comes with those is another incredibly useful option that you should always keep in mind, especially if you're building tools that others will be using. You can fill these in with notes about what the parameter is intended to do, maybe some bonus tips on ranges to avoid or certain situations where it might break. Another quick organizational tip is with function inputs and their variables. They can essentially be used like local variables, in that instead of having all these wires linking back to the original input node, you can clean it up really easily with a simple get and the name of the parameter that the wire is going into. Oh, and hopefully it's obvious, but you should definitely be naming your parameters and inputs better than I am in these examples. Another really important option to keep in mind is how you organize your variables and the data that you're inputting. And thankfully there are quite a few options. My favorite that we'll start with are data assets. They're one of the newest additions and definitely one of the most powerful. You can use them as a simple variable organization and list, or full-on blueprint functionality, kind of a secondary function holder. To create one, you first have to create a new blueprint in the content browser, and instead of picking from the usual list of buttons up top, you want to expand the little list at the bottom and look for the primary data asset. Select that, name it appropriately, and open it up. From there you'll see what looks like very much a regular blueprint, but it's a bit emptier, and here's where you start filling in just what you need. So if you simply want a list of parameters that you can use elsewhere, you can do that, add to the variables list. If you want to add a little functionality that you want to call from it, you can do that as well. There's quite a bit to dig into here. Whatever you need, fill that in, compile, and then go back to the content browser. Right-click, start typing data asset. Select that once it comes up, and now search for your class type. You can kind of think of that as a preset again, so you can change any of the default values here that you want to always show up when using this data asset. You can duplicate that, set different defaults, and then back in your blueprint, your new parameter that holds all of those variables, you can select which one that you want from that type of data asset. The next useful and fairly new addition to options for replacing a lot of variables is the tag holder. You can think of this as a project-wide list of bools, but they have their own categories and nesting. So you can have one bool that has 3 children, and maybe one requires all the other or not. There's quite a few options you can go with here. The new variable in your blueprint just needs to be of the tag container type. You can add new gameplay tags within these options here that I'm showing you, but it's a little easier to work with if you open up the Manage Gameplay Tags option. Now you can move all those Boolean variables into this tag manager, sort them as you like, group them, quite a few options there. And then instead of checking for all these individual bools and having to recreate those booleans across multiple blueprints, you just have this one tag holder. And if you ever want to check whether they have them or set them, there's a couple of these has tag or set tag nodes within blueprints. Structures are another option for organizing your variables and your data across multiple things, not just in blueprints. But these are one of the older features of Unreal, but definitely still worth keeping in mind. To create one, just right-click in the content browser and start typing struct. Select that, name it, and start filling it in. You can really only make a list of variables with this, but it's still quite handy to set up anything that you know you're going to need to reuse or anything that you want to keep together. It's nice how quickly you can change or add variables and they kind of propagate it across everything that they're being used in. But do keep in mind there's still a strange crash issue where if you change, or especially if you remove a parameter that's being used somewhere else in a struct and then try to save that in another blueprint, especially if it's already open, there's a pretty good chance it'll crash or just won't update properly. The last option here I want to touch on are data tables. These are more for just really big sets of data, item balancing, crafting options, crafting data, just anything that basically requires a spreadsheet or is actually built in a spreadsheet outside of Unreal and you want to import it as a similar table again. This is the way to go. It can get a little unwieldy and the interface isn't the most friendly to work with, so searching through their data during runtime can get a little heavy too, depending on how big it is and what kind of search you're doing. But to create one, just right click in the content browser again, type data table and select what sort of format you want to use. Notice that you can use a structure that you've created before. This part is about component mobility, the static, stationary, and movable option that you see on pretty much everything in the world or in a blueprint. Whenever you add something to a blueprint, it pretty much always comes in as movable, which is fine in a lot of cases, but for static meshes, they really should be static. Same goes with instance static meshes, hierarchical static, anything that's going to be rendered mostly. It's not a bad idea to set lights to static as well, but in most cases now with Lumen, and especially with megalights, it doesn't matter. Not leaving them as stationary is not a bad idea though, so you don't get all the warning about stationary overlap. You can see here when you're placing a regular static mesh into the world, it'll default to static, which is great. But since blueprints do not default to static, it might be easy to miss setting that. Fortunately, there's one option for checking that just across the world at a glance, and that's this player collision view. Anything you see purple is set to movable, so it's probably a good indicator that you want to set it to static unless you truly need it mobile, like it's a moving platform or a rotating fan. One other case where you might need it mobile, at least for a brief moment, is when you're first spawning in an object and you want to set its position or adjust its rotation, then you want that to be mobile. But afterwards, there's no reason not to set it back to static in most cases, and again, that'll save you a bit on performance. Time for a little material tip. In older versions of Unreal, the only way you could really dynamically influence the materials on your objects was this dynamic material chain, or the set material parameter, which kind of created a dynamic material in the background. This option still works alright, but it should definitely be used more limited or one-off situations. To use that way, you just need a parameter with the exact name as it is in the material used in the blueprint as well. The new nice method is custom data, and it works in a similar fashion in that you need the node set up in the material beforehand. The name doesn't matter anymore, it's the custom data index that's important. It'll be referenced in the blueprint. You can see here both methods come out with the same results, just a random color per instance. But the big difference is what it's costing you on rendering. With a dynamic material version, it's essentially creating a new material for every single instance. It's a new render path. Custom data, however, is kind of all magic on the back end, and it's keeping it all as one instance, one draw call. The only downside that I've found so far with custom data is if you use too many custom data indexes, nanite base pass in the rendering set will get a little more expensive. It's generally quite a small increase on more modern machines, but if you're trying to do a min-spec build, do keep in mind that cost increase because it can scale up quite a bit. Hard references are a similar problem to casting I mentioned before, where It requires that you load all of that data's information in with the blueprint as soon as it's referenced, sometimes permanently if it's a parameter default. You can check those references and what's loaded by right-clicking any asset in the content browser and looking at the size map. The reference viewer is another great option in the kind of same regard. The size map's nice and quick though. Here you can see that this demo blueprint has this camera shutter audio file permanently attached to it. That's because of that little print function that we set up before. But overall it's fairly small, 900K. Let's make a mess of that. So with our myActor parameter, instead of leaving it empty by default, let's set something, check the size map again, and boom, it has exploded. So now anytime this demo blueprint is read or needed, it also has to load in this huge sky dome. All its textures, all its meshes, everything comes with it. It's one of the main reasons why you want to keep parameters like that empty or null by default. But if you have to have something in there, that's another reason for a soft reference. Unlike hard references, soft references are basically just a path telling where the object is instead of forcing all of it to be loaded immediately. It does mean that you have to do a little extra work in the blueprint to load it, but at least you get to control when it's loaded. I don't show it here, but to change a soft reference into a hard within your blueprint, you drag out that parameter, async load, or load blocked. There's a couple options there. And then use that output to cast to whatever type of thing it is, and then either spawn it or you can do whatever you need to do with it from there. Another great feature within Unreal is the idea of a child blueprint. Best way to think about these, I think, is a kind of a tiered preset. So your top level blueprint should be relatively empty. It just holds the main parameters and functionality that you want all the children to use. And the child of that will hold any extra unique functionality for this branch of the blueprints, or any defaults that you want to set once and not have to repeatedly set again. Like here, I created a duplicate of the original instead of a child just within the world, and I'm changing the mesh to be a cylinder. And while that's definitely an option, it's a pretty terrible one the further you go on a project. It's only saved to the map, and it's a bit difficult to see or track down if you have bugs with any kind of internally changed options like this. Instead, a better way to go is to right-click your original blueprint in the content browser and choose the child blueprint option up top. Now you can change that static mesh to be whatever you like. You can add more components or even change the defaults of any of the parameters that are on the base. You can also add any additional variables or functionality that you need for this particular set of child BPs. You can keep chaining that down to get child BP inception all you'd like, but generally you only want one or two parent level blueprints so you don't go totally crazy bug hunting or looking for any other issues. One nice feature to remember though is that the parent blueprint is always linked in the top right, and you can browse to it or directly open it up for edit with that little magnifying glass and pencil icons. You can also change what that parent blueprint is in the class settings. Just keep in mind that if there are any overlapping parameter names or function names, you might have some issues to clean up afterwards. Nearing the end of this set, but one of the last tips I want to give you here is to test. Test your blueprints often and regularly. Save yourself a whole lot of headaches down the road. It doesn't take much either. Even just dropping the blueprint into the world and opening your output log, seeing if any warnings or errors come up is a pretty good start. You can clear the log to make it a little easier to read, and there's also quite a few filter options. Trim down what you see. I added a print string here just to give myself a little reminder, a note when something isn't going to work. It's a great way to use these as quick debug tools or even reminders to your entire team if something needs to be set that isn't. And then this goes back to those valid checks we were talking about earlier. If the actor parameter isn't set on these and then you hit the play button, you'll see all these warnings pop up because it can't spawn a null actor or a null class. And while these are just warnings, this is a good reminder of why you should test, especially placing one in the world and playing, because this will give you warnings that you wouldn't get otherwise. And the warnings themselves aren't going to stop anything generally. They're not going to break gameplay, but they will spam the log and your team to no end, especially if there are a lot of these placed in the world. Now with that valid get, no more spam. And a less likely chance of actual errors and crashing problems down the line. This last tip is a pretty light one, but it tends to have a lot of uses, and that's text and string formatting. Text and strings can be converted back and forth pretty easily, very quickly, so you can use functionality of one into the other. Most of what I've showed you so far with strings and the print strings is really just for simple debug, but there are a lot of other options as well, especially once you get into UI widgets and any text display that you want to show to players. So keep these text formatting and string appending options in mind, because you can make some pretty powerful edits dynamically with these. The append string node's pretty simple, just as many pins as you want for as many inputs as you like. And those inputs could be as simple as a blank space if you just want a gap between other inputs. Format text option is kind of nice though, where you can have different inputs that are actual variables, or at least act like variables, and that they don't have to be text or string. Type in whatever you want printed out, and then anything you want as an input, you add the curly brackets around and it'll automatically add the input pins underneath. There are a couple really handy hidden options on the print string that are worth keeping in mind too, especially for debug. The key is one of the best for avoiding just the wall of spam. Anything you set there will make it so whatever this prints is only updated to that single line, and each object, or at least each thing with a unique key, will only print to that one line. And of course color and duration are handy options as well. That's about it for now. Hope they've been helpful, and as a nice bonus to all of this, if you're working with others especially, now you don't have to worry about hearing their cries of terror when they open your spaghetti monster blueprints. I've seen that a few times myself and still shudder. There's always more to dive into, especially with some of the more unique cases with UI widget blueprints and character animation blueprints, but that's it for this list. I'll also add a few links to some of Epic's best and more recent presentations regarding blueprints and some of the tips that we've gone over today. But hope that's helpful, and have a good one.